Hi, welcome back. In this session, we will discuss fluid properties. Fluids, whether liquids or gases, have different properties that define their behavior. These properties may include mass density, weight density, specific volume, specific gravity, viscosity, and so on. In this session, we will explore few properties of fluid: mass density, weight density, specific gravity, specific volume, and viscosity. Mass density or density is how much mass is packed into a given volume of substance. You can think about its heaviness. Different fluids have different densities. For example, air is much lighter than water. Mathematically, we can define the mass density as rho is equal to mass m divided by volume. So it is the ratio of mass and volume. The unit of mass is kg and the unit of volume is cubic meter. Therefore, in SI units, it is expressed in kg per cubic meter. Now coming to the weight density or specific weight. Specific weight or weight density is how much weight is packed into a given volume of substance. The specific weight is denoted by a Greek letter gamma. Gamma is equal to weight W divided by volume V. This weight can be written as mass times the acceleration due to gravity, mg, divided by volume V. In SI units, the specific weight is expressed in Newton per cubic meter. Now coming to the specific gravity. Specific gravity is the ratio of the mass density of the fluid to the mass density of the standard fluid. Specific gravity is denoted by a letter S. So, S is equal to rho F by rho W. Rho F is the mass density or density of the fluid for which we are going to determine the specific gravity, and rho W is the mass density of the standard fluid. We consider the standard fluid as water for liquids. So, S is equal to rho F by rho W. The specific gravity can also be determined by using the relation gamma F by gamma W. Gamma is the specific weight or weight density of the fluid. Since on the numerator and the denominator both are in the same units, therefore the specific gravity will not have any unit at all. Now coming to the specific volume. Specific volume, V is the reciprocal of the mass density. So, V is equal to 1 by rho is equal to the volume V divided by mass m. In SI units, the specific volume is expressed in cubic meter per kg. Now let us jump into the viscosity. Viscosity is a fluid's resistance to flow. Imagine the flow of honey and water. Honey is more viscous than that of water. We know that. Now coming to the definition of viscosity. Viscosity is the property of a fluid by virtue of which one layer of a fluid offers certain resistance to the motion of the adjacent layer. Let us consider this is one plate and this is another plate. The plate 1 is fixed. Between the plates 1 and 2, some fluid is filled. When we apply certain force F on the movable plate, the fluid particles that are adhering to the fixed plate will have zero velocity, whereas the fluid particles that adhere to the movable plate will have the same velocity as that of the movable plate. So, here the velocity is 0, here the velocity may be, say, u. So, this layer offers a certain resistance to the motion of the next layer, and this layer offers a certain resistance to the motion of the next layer. This layer offers a certain resistance to the motion of the next layer. The Newton's law of viscosity states that the shear stress at tau is directly proportional to the shear strain phi. What is the shear strain here? It is the rate of angular deformation. The rate of angular deformation is, if we consider this as phi, this is du and this one is dy. Consider this is the one layer of fluid, this is an adjacent layer of fluid. The distance between these two layers is dy and the change in velocity is du. The angle phi is equal to du by dy. That is, tan phi is equal to du by dy. If the angle phi is small, we can write phi is equal to du by dy. So we can write tau is directly proportional to du upon dy. Is directly proportional to u minus 0 divided by y, where u is the velocity of the fluid particles that adhere to the movable plate, and the velocity of the fluid particles adhering to the fixed plate is 0. And the distance between these two is y. To remove the proportionality constant, we introduce a term mu. So, tau is equal to mu times du dy is equal to mu times u by y, where mu is the coefficient of viscosity or coefficient of dynamic viscosity or dynamic viscosity, or simply we can call it as viscosity. Now let us discuss the unit of viscosity. Tau is equal to mu du dy. This can be rewritten as mu is equal to tau upon du dy. And the unit of the shear stress is Newton per meter square. Unit of the change in velocity is in meters per second, and the unit of dy is in meters. So, the unit of the viscosity or dynamic viscosity or coefficient of viscosity or coefficient of dynamic viscosity is Newton second per meter square or Pascal second. Most of the time, we would have come across with the unit of poise. 1 poise is equal to 1/10 of Newton second per meter square, or we can say that 1 poise is equal to 0.1 Newton second per meter square, or 1 poise is equal to 0.1 Pascal second. Now let us consider a shaft of diameter d rotating at an RPM of n. The tangential velocity of the shaft can be determined by using the relation u is equal to pi d n by 60. Between the shaft and the bearing or journal, some fluid is filled for the lubrication purpose. The tangential velocity of the fluid particles that are adhering to the journal will be 0. Why? Because the journal or bearing is a stationary element, whereas the shaft is rotating at an RPM of n. So, this will have some certain velocity u. That u is the tangential velocity pi dn by 60. And we can determine the change in velocity. The change in velocity is equal to u minus 0. From this, we can determine the power lost due to friction. P is equal to the shear force multiplied with the velocity. That is the tangential velocity. Now coming to the kinematic viscosity. Kinematic viscosity is the ratio of the dynamic viscosity mu and the mass density rho. Mu is equal to mu by rho. The unit of dynamic viscosity is Newton second per meter square, and the unit of mass density is kg per cubic meter. On simplification, we obtain the unit of the kinematic viscosity is meter square per second. Sometimes we use the unit for dynamic viscosity as Stokes. 1 Stokes is equal to 1 divided by 10 to the power 4 meter square per second, or 1 Stokes is equal to 10 to the power negative 4 meter square per second. What are the topics we have done? We have discussed about mass density, specific weight, specific gravity, specific volume, and viscosity. Thank you. Bye-bye.